match what ends up in unwind tables. And so I've been diagnosing that issue to try and figure out, why they're not matching up. Like what is preventing the unwinder from finding the information it needs to unwind through that function. And it might be that the layout is a little bit off, or it's looking in the wrong place. But stepping through the code, one of the problems on Mac OS is that we have to use the Mac OS provided system lib unwind, and because of that, we don't have source code for that. So the disassembly is just raw assembly, and it matches fairly close to the source code that we have shipped as part of Lumen, but without having the real source, stepping through that is very difficult to figure out exactly where it goes wrong. So I was looking for some tooling to try and dump a little bit more metadata so I could look at that and see where things maybe don't match up. LLDB actually has some useful tools there, and so I'm currently looking there to see if I can figure out like what's going on. The interesting thing is if I dump a backtrace in LLDB, it obviously sees the full trace. And if I use some of its tooling, it can compute unwind information for that function. But it seems like, part of that is due to LLDB doing some extra work above and beyond. So I still need to figure out why that's, going south at runtime. But that's really the last thing in the way here. I don't have a good answer on, when I'll have that solved here, but I hope it's not going to take too much longer. I mean, at this point, if I can't get what I need from the unwind metadata here, I'm just going to step through the debugger, bit by bit, match it up with the source code in the unwind library, and reason about what conditions are failing. My assumption is that the instruction pointer that it is working with is incorrect. So when it goes to look for that instruction pointer, it's using the wrong thing. It's basically using an address that doesn't match up to any function. But I need to figure out where that's going south, or what it's actually using as the instruction pointer address. And I have a fairly good idea how to get that easily, but because when I was stepping through the disassembly before, there were a few times where I saw it grabbing the instruction pointer. So I'll probably just have to take a look at that. Anyways, that's more or less it for me, I guess, for now. That, most of last week was when I had time fixing up some odds and ends in that PR, some bugs I found after running the full test suite, but that's about it.
When you say we don't have the source for libunwind from Apple, it's not the copy on opensource.apple.com? Like it's a different version than that?
That probably is it. I'm saying that like we don't have like the actual debug info on the machine. So if there's a difference, say, between the version I have on my machine and the version on yours, I won't see that stepping through the code, obviously. And even though the source is up on that page, there's no way for us to map that to stepping through the code.
Yeah, they give it as an Xcode project. I wonder if we build it, if it'd be possible to substitute the debug info from the one we build with the real one, but I'm not sure. I've never tried to build the the code actually on opensource.apple.com, but check that.
My assumption, what I understand, Apple provides debug info, but it does not provide the sources. So I haven't looked to see in LDB if I can like force it to use a particular file as, you know, the source. Even if it's not 100% accurate, it's probably good enough. Like that code hasn't changed a whole bunch. So
Yeah.
that might be sufficient to step through it. Honestly, it would make things a lot easier. I'll probably check that before I actually step through the disassembly again, but yeah, it's very fun.
Yeah, the other thing to check is I know for reporting bugs Apple, you could check the output of sys diagnosis, the reporting tool, like when it says, do you want to report a bug to the developer, and see if it has a crash dump that's more helpful in it. But I don't know if it'd be anything different than what you can already see in LLDB. It's just a guess, though.
Yeah, I don't think so. I mean, I can get quite good information from LLDB. It's just when it comes to stepping through the code to see what it's actually doing, you know, I'm having to like map the assembly back to the original source code, which is sometimes a bit painful. Luckily, a lot of that source is pretty simple, like it's not doing anything real crazy. So the job of like mentally reassembling the code in your head is not like crazy difficult, but it's still tedious, very tedious, especially because a lot of stepping through is like, there's a couple places where it's doing loops and like searching through the stack for things. And because there's no way to say skip, you know, to the next time that I hit this branch in the raw disassembly. I mean, once you figure out the memory address, then you can tell it to break there, but it's just very, very annoying. Just sitting there like stepping.
A potential option also is just on the LVM mailing list, there was a thing about Facebook's Bolt framework, and one of the things they say that it's useful for is it can create a control flow graph from a binary that you don't have the source for, because that's how like it does optimizations in the binary level without having the source. And so you could do that to, you know, disassemble it, or, you know, almost decompile it, because it'll have a control flow graph. I don't think it goes all the way back to C, but it will give
the
the
problem
control
with a
flow
lot
graph.
of the unwind stuff is that it is completely opaque to, you know, a lot of those toolings, because what it's doing is like, you know, saving registers and then jumping to another address in the code.
It's a thing to just see if Bolt understands libunwind enough that it makes it easier to think
I guess
about.
if it's operating on the raw assembly, then that might work.
Yeah.
In fact, LVM objdump also has a similar kind of tooling where you can tell it to dump a control flow graph.
Yeah, on the actual thread, the Bolt people from Facebook said it's better than the one in objdump right now.
Yeah, I believe that. I think the one that's there is kind of, you know, an example more or less, or something that works in the general case, but I'm sure they put a lot more effort into making it handle a lot of edge cases better. The tool I'm playing around with right now is a plugin for LDB. If you, excuse me, if you do, I think it's import LDB.diagnose or something. Here it is. It's command script import LDB.diagnose. It imports a very useful tool called diagnose unwind that dumps a lot of useful unwind information based on your current position in a thread. So that's the most useful thing I found so far. And it's not doing anything super unique, but it is, cleaning up and making use of all the various information that LLDB already has and giving you kind of a more useful dump of information.
Do we know? So I assume the LLDB that we built. Well, actually, wait. When
I
you're
don't build
using
that.
LLDB, right? Okay, so we're using the one that ships with our Macs, and that one is. But is that one using the libunwind that ships with LLVM, or is it using the Mac one? I'm just wondering, like, is it?
Oh no, it's using the lib unwind that ships with Apple.
Okay.
I
Because
mean, for
I
one thing, the LDB that I'm actually using is the one that ships
okay.
from Apple. But on top of that, it's stepping through code or, using the information produced by our compiler. The only exception to that is for it does like assembly language inspection to
Mm-hmm.
work out an unwind plan. And that's like the fallback for LLDB. And it does a lot more than, it doesn't rely purely on exception handling information and stuff. That uses whatever, stuff it was built with, which might be different than the system lib unwind, but is probably unlikely to be different. I'm assuming
Okay.
all of the LVM tooling is built together and shipped together.
I was just trying to figure out why the backtrace command would work when that should be literally the same as libunwind. That just seems odd to me.
Oh, I mean, what do you mean, backtrace?
Well, when you do backtrace, that's like showing you the frames that libunwind would walk through, and like, why can you said that could see the frames, even though when we actually
Oh,
use
yeah.
libunwind, it can't. And I'm just trying to think there has to be a version difference somewhere between there. Then if it's
No,
okay.
what the difference there is that LDB is not relying purely on what's baked into the binary. It, like I said, is basically looking at the disassembly
Mm-hmm.
and working out where things are on the stack so that it can properly unwind, even if there's no unwind information present.
Okay.
So you can generate an executable with functions that have no unwind info,
Mm-hmm.
and LLDB can still generate a backtrace because
Right.
it knows how to walk back up.
Do we? I know when I used to do Gentoo, this was a problem. Do we do that optimization where we get rid of stack frames that aren't, or the stack pointers that aren't necessary? I forget what the optimization is. Where like your stack frames disappear because like it's extra stack space you don't necessarily need. We're not optimizing those out, are we?
Um, I'm not 100% certain what you're referring
I'm
to,
trying to
but
remember.
I
Yeah.
don't. We're not stripping any. Like we're not compiling with omit frame pointer or
Oh, that's
anything
what I
like
say.
that.
Oh, yeah. Omit frame pointer. We're not. Okay. So we stop that. Okay.
Yeah, and I mean, in any case, where even if we were compiling with that, the way the stack is being set up, the frame pointer is being pushed onto the stack anyways, and then the door debugging information uh, identifies where to find that frame pointer, and
Okay.
also the return address and things like that. Um, and that's where I'm kind of assuming the problem lies, is that CFI directive is incorrect, or the way the stack is being laid out doesn't match the like implicit directive that applies there. And that's where I need to kind of figure out what's going on. Rust
Well,
2 is kind of contributing to the problem a little bit because there's no way for me to dump the directives that it is implicitly compiling. That maybe that's more of an LVM issue. I don't know. Could have sworn there was a time where I could actually see. Oh yeah, if with LVM, if you tell it to dump the assembly source, you can see the CFI directives that get produced. And I have looked at that. The problem is in this case, I can't, at least I haven't found an easy way so far to dump the assembly source for the executable we're producing. So because this function is in the middle of liblumen core, I would have to dump, presumably I have to figure out how to compile and emit the assembly for that whole library and then take a look through there. I haven't tried doing that yet, but that's another option as well.
Well, shouldn't any of the disasm tools do that for you? If you, I don't know if we do the
No,
CFI.
they don't show the CFI directives, unfortunately.
Okay.
That's one thing that I wish they could do, but basically the reason it doesn't is those are converted into, DORF debugging information in the executable.
Hmm.
So the directives aren't actually present in the disassembly. The information is in the executable and is used for unwinding and stuff like that, but
I'm wondering
the
if any of
actual
the
source directives are gone.
reversing tools for InfoSec would do the CFI for you. I mean, probably not because it probably isn't important enough.
I mean, LVM can emit that assembly source for us. It's just kind of a pain to get because there's no way for me to compile the executable and say, hey, while you're doing all this compilation, generate the assembly source for this module.
Mm-hmm.
Instead, I have to be like, okay, I'm compiling this specific crate, dump the assembly source for the whole thing, and then go dig through that to find the specific function that I'm looking for. The problem is, I have to go in and custom compile liblumen core with the correct flags to do that.
Mm-hmm.
And it's not a huge deal. It's just one of those things that we don't have any automation or tooling around.
Okay.
And ultimately, the thing I'm most interested in is when the actual executable is running, what is there versus what's missing. Like I could dump the assembly source for liblumen core, find the function, see the CFI directives, but is that information actually present in the final executable? Like those are kind of the questions I have. So I've been working backwards from the executable in the hopes that, if something's just straight up missing, that tells me more than dumping the assembly. But so far, it's not clear to me. Like I fixed a few bugs that were because unwind information was just missing. But now that that's not a problem anymore, it's a different, more nuanced issue now.
So is that pretty much your whole status then?
Yeah.
Okay. My status isn't much. I'm on client work. So I landed the stubs that make seek trace link, and it actually then once it links it compiles completely. So we have another one that compiles. So that's great. There's no more weird compile stuff that affects seek trace. Okay, Hans, your status?
Yeah, so some work on getting the changes merged into hash brown, which seems to be fairly close now. It's just some small things that need to be resolved.
Awesome.
And also the same with Bumpalo, but that's slightly blocked by the hash brown thing. And other than that, working on attributes, function and module attributes, and also the issue with patterns in binary generators for some reason behaving completely differently than binary patterns everywhere else in Erlang. So that's a fun one too.
What do you mean in terms of they're different than they are everywhere else?
So, okay, this is a really fun and interesting one. So in with regular patterns, you either have like the concept of either it matches or it doesn't match at all, right? Which is like sort of what you would expect with a pattern. The pattern either matches or it doesn't. With binary generators, in binary generators, a binary pattern is applied to a bit string several times, right? That's how the generator works.
Yeah.
It sort of strips out the head of the bit string every time. So then you might ask what happens when, say you have constants in your bit string pattern in a binary generator, and a pattern suddenly does not match the bit string that you're generating over. I mean, I would expect it to sort of like throw an exception or something, but what it does is that it, in case a constant doesn't match, it just ignores that constant that doesn't match, consumes the data anyway, and continues on to the next iteration.
Sure. Yeah, that makes sense. That is interesting.
Yeah, so that's like sort of, I have to add a separate mode to my lowering logic for patterns to handle that sort of mode of operation. Yeah. So you sort of have the concept of a partial match where like the structure of the pattern matches, but the constants or like auxiliary like pattern pieces doesn't match.
Did you check the Beam book to see if there's like a historical record of that the author found of like why does it work this way?
I read the original paper, but the interesting part is that the behavior described in the Erlang paper on binary generators or binary like comprehensions, the behavior in there does not match the behavior that's actually in Erlang in some like subtle ways, which is I don't know, it's interesting too.
Yep, Beam is the spec, unfortunately.
Yeah.
That's kind of unfortunately the case with a lot of those papers. They're like old enough now where they're useful for historical purposes, but they don't actually match the way things work, really.
Yeah.
We are quite lucky, though, that, there were a number of papers written about, early Erlang attempts at different things, like ads, binaries.
Yeah, I mean that was certainly like the paper on core Erlang, although it was like really, really outdated and really different. It really helped me to implement it. Like it gave me the starting point, and then I could just fix the issues as I saw them from what I implemented initially.
Yeah, I think that was my favorite one out of all of them, to be honest, because you could really see the elegance of the language itself when it's compiled down to core. But and honestly, if you wrote a type system to work on core, you could probably use all of the research that's been applied to ML for that, since there's so much overlap there. But that's probably diverged a little bit now. Because a lot of the research around like type inference algorithms and stuff typically use ML as like the lingua franca for that. And in general, a lot of the type inference research is around not having any type annotations at all.
Yeah, the core Erlang is like really lambda calculus-y.
Yeah.
So I imagine that helps a lot.
Well, I don't know if there's anything else really to report. I think, in the next day or two, I should have this unwind issue wrapped up. And, we can get that branch merged finally.
Nice.
And then we can start focusing on some of the, other issues that have been opened that are related to, the release, which is namely fixing the Linux build, I guess. I'm not sure if there's anything else that's a critical bug. We'll have to reevaluate, I think, a lot of the OTP compilation with, the new branch merge, but I've been running, the tests that you wrote, Luke. And those have been very helpful in terms of, surfacing issues.
Yeah, I can do the build log diff on Friday when I have time to work on Lumen, assuming it's merged by then.
Yeah, that'd be cool. The other thing that I am going to spend some time on after I address those two other issues is adding, some fundamental support for compiling from, a .app, because that'll give us a lot more flexibility, and I can actually do proper, merging of translation units and things like that. So that will help us in terms of optimization, being able to figure out, what symbols we can strip and things like that. So that's it for me. I don't know. If you guys have anything else, I guess post it in the Slack channel and we can talk again next week.
Okay.
Take care.
Bye.
Bye.